ray diagram for a converging lens when the object is between the focal point and the lens itself. We start with our parallel ray of light. If the ray of light is parallel to the principal axis, it will be refracted through the focal point, and we put an arrow on showing the direction that the light is travelling in. A ray of light travelling from the object and going through the very centre of the lens will not be refracted at all, so it will carry on going in a straight line. And I'm just struggling a bit with my dodgy ruler here, so I'll just have to go over that little notch. There we go, and fill that gap in, sorry. And again, we'll put our arrow on to show the direction that the ray of light travels in, but you can see that the rays of light do not meet up, they don't focus anywhere. So what we're going to do next is we are going to continue those rays of light as if they came through the lens in a straight line. So these are virtual rays of light that we're drawing now, so we draw them as dotted lines. And if we continue those virtual rays, well, what we do is we continue those virtual rays of light upwards until they cross over. See, I've just got to continue this one a little bit further. Now, where those rays of light cross over is where the image will form, so we can draw that on. And we remember that we were drawing rays of light from the top of the object, so that means that we've got to draw the top of the object where the rays of light cross over. So you can see this is a virtual image because it's formed from virtual rays of light, can't be projected. So if we imagine an observer on the right-hand side of the lens looking through it, then what they would see is actually an image that is magnified by the lens. We can see that that image is the correct way up, and we can see that it is a virtual image. There are virtual rays of light and it is not being projected.